Hello students, welcome to your mathematics class. Today in this video, you will learn about the chapter Polynomials. In this video, my discussion topic is remainder theorem and some related problems. Now we have seen that when we divide a natural number by another natural number, we get the remainder either 0 or the value of the remainder is less than the value of the divisor. Now, let us see some examples when we divide a natural number by another natural number. Let us see the first example. Divide 72 by 2. Here 72 we call it as the dividend and 2 as the divisor. The division is already shown here. So when we divide 72 by 2, here we get the quotient as 36 and the remainder is coming here 0. So in this case, we can express the dividend, that is 72, as the product of divisor and the quotient plus remainder, that is 0. So we can write here dividend as dividend is equal to divisor multiplied by quotient plus remainder. Now let us see another example when we divide 75 by 4. So here 75 is the dividend and 4 is the divisor. So after doing the division, here we get the quotient as 18 and the remainder here we are getting 3. So here also we can express the dividend, that is 75, as the product of divisor and the quotient plus the remainder is here 3. If you just do this calculations, you will get the result as 75 because 18 4s are 72 plus 3. You will get 75. So from these two examples, we can see that we can express dividend as the product of divisor and quotient plus remainder. But observing the remainder of these two examples, we can see that the value of the remainder will be either 0 or the value will be what? The value will be less than the value of divisor. So from this example, we can see that when we divide a natural number by another natural number, we get the remainder either 0 or the value of the remainder will be less than the value of the divisor. Now you have already learned how to divide a polynomial by another polynomial. Now let us see one example. Now let us see the division of polynomials. That is, when we divide a polynomial by another polynomial by long division method. So before doing the division, first we have to express the given polynomials in their standard form. That is by arranging the terms of the polynomial in the decreasing powers of the variable. Now let us see one example. Divide px is equal to x plus 3x square minus 1, which is here the dividend, by gx is equal to 1 plus x. Here in the first polynomial, the highest power of the variable is 2, which is written in the middle term. And in the second case also, the highest power of the variable is 1, which is also written in the second term. So first we have to arrange the terms of the polynomial in the decreasing powers of the variable. So the first polynomial becomes 3x square plus x minus 1, and the second becomes gx is equal to x plus 1, which is the divisor here. So we write the divisor here, x plus 1, and 3x square plus x minus 1 as the dividend. Now, to get the first quotient, in this case, first we need to divide the highest degree term by the highest degree term of the dividend by the highest degree term of the divisor. That means if we divide 3x square by x, here x is the highest degree term of the divisor, so x, we get here 3x. So which will be the first term of the quotient. Now we need to multiply this first term of the quotient with the divisor. So whatever the product we will get here, we will subtract with the dividend. So 3x square plus 3x. Now we will subtract them. So we will change the sign of the terms of this product. So this plus becomes minus. So both having the same value, same coefficient of x square, but they are opposite in sign. So this two will cancel out. They become 0. So 0 into x square we will not write here. Now here plus and minus. So minus 3 plus 1 becomes minus 2x. Then we bring down the next number, that is minus 1. So now we see that here we get the new expression minus 2x minus 1. Now here we can see that minus 2x minus 1 is the expression whose degree is 1, which is equal to the degree of the divisor. So in this case we need to continue the division process until we are not getting the remainder 0 or the degree of the remainder less than the degree of the divisor. So here let us find the second term of the question. So here also we need to divide the highest degree term of this expression, that is here we call it as the new dividend. So minus 2x by the highest degree term of the divisor, that is by x. So this 2 will cancel out, we get here minus 2. So the next term of the question will be here minus 2. And what we will do here, we need to multiply this divisor, the same divisor, by this, the quotient, that is next term of the quotient, that is minus 2. So whatever the product we will get, that we will subtract from this new dividend. So here we get minus 2x and minus 2. Now again we are subtracting, so we change the sign of this terms of the product. So this becomes plus, this is also plus. Now here we can see that here the coefficient of x is minus 2 and here it is plus 2. So both are opposite in sign, so they will cancel out, and here plus 2 minus 1 becomes plus 1. So here 1 is a constant polynomial whose degree is 0, because 1 can be written as 1 into x to the power 0. So degree of this 1 is 0, which is less than the degree of the divisor, that is 1. So as we get the degree of the remainder less than the degree of the divisor, so we stop our calculation. So here in this division process we can see that we get the question here 3x minus 2. This is the remainder, that is 1, and here the divisor is x plus 1, and 3x square plus x minus 1 is the dividend. So here we can express the dividend, that is what? 3x square plus x minus 1 as the product of divisor and the quotient 3x minus 2 plus remainder. If we find the product of this divisor and quotient and then we add with 1, we will see that we will get the result dividend. Now here in this example we get the remainder 1, which we got by doing the division, by doing the actual division process. Now if we replace the variable of the dividend by the 0 of the divisor, then what will happen? Let us find out the 0 of the divisor. Here 0 of the divisor, that is x plus 1, is what? Is minus 1. So if we put x plus 1 equal to 0, we get x equal to minus 1, which is the 0 of the divisor. So 0 of the divisor, here x plus 1 is minus 1. Now if we replace the variable x of the dividend, if we replace the variable x of the dividend by 0 of the divisor, by the 0 of the divisor, that is minus 1. If you replace x of the dividend by the 0 of the divisor, that is minus 1, then we get p of minus 1, that is in place of x we will put here minus 1, which is the 0 of the divisor. So that will be equal to 3 of minus 1 whole square plus minus 1 minus 1. So we get 3 minus 1 is equal to 3 minus 2 equal to 1. So whatever the value we are getting, that is p of minus 1 is equal to 1, which is same as the remainder we get by doing the actual division process. So both the results we are getting the same. In this example, we can see that we get the remainder by doing the actual division process is same as if we replace the variable of the dividend by the 0 of the divisor. So if we do some more example, we get the same similarity. So with the help of this example, now we will see the remainder theorem. So now by division algorithm for polynomials, we can say that if px and gx not equal to 0 are any two polynomials such that degree of px is greater than equal to degree of gx, that means the degree of the dividend is greater than equal to the degree of the divisor, then we can find polynomials qx, which is called the quotient, and rx, which is called the remainder, such that px is equal to gx multiplied by qx plus rx. That means dividend is equal to divisor into quotient plus remainder. Here the remainder is either 0 or the degree of remainder is less than the degree of the divisor. This result is known as the division algorithm for polynomials. Now let us see the statement of the remainder theorem. Let px is any polynomial of degree greater than equals to 1 and let a is any real number which is the 0 of the divisor. If px is divided by the linear polynomial x minus a, then the remainder is p of a, that is p of 0 of the divisor, or in other words we can say that we get the remainder is equal to value of the polynomial px at the 0 of the divisor. Now let us see the proof of the remainder theorem. Here px is divided by the linear polynomial x minus a. So we consider here px as the dividend and x minus a as the divisor. If we consider qx as the quotient and rx as the remainder, then by division algorithm for polynomials, we can write the dividend as the product of divisor and the quotient plus remainder. So in this case, either we get the remainder equal to 0 or remainder not equal to 0. So let us consider the case when remainder equal to 0. That time this equation 1 becomes px is equal to x minus a into qx because rx becomes 0. Now if we put x equal to a in equation 2, that is by replacing the variable x by the 0 of the divisor. So if you replace x by a, in this equation 2 we get p of a is equal to a minus a, which becomes 0. 0 into qa, that whole becomes we get 0. And we have considered here the remainder 0. So we get the pa is equal to 0, which is same as the remainder. Now let us consider the case when the remainder is not equal to 0. So in that case degree of the remainder will be less than the degree of the divisor. So here the degree of the divisor, which is x minus a, is 1. Then the degree of the remainder will be 0 because degree of remainder is less than degree of the divisor. So here we consider the degree of the remainder is 0. Then the remainder will be a constant polynomial. So let us consider for every value of x the remainder as rx equal to capital R. Then we can change this expression, that is px is equal to x minus a into qx plus rx. In place of rx we will consider here as r. So we consider px is equal to x minus a into qx plus r. Now if we replace x by a in this equation 2, we get pa is equal to, here a minus a becomes 0. So 0 into qa becomes total 0. So we get this equation 2 becomes pa is equal to r. Hence the remainder is pa when px is divided by x minus a. So in this case, when a polynomial px is divided by a linear polynomial x minus a, then the remainder will be p of a. That is, we get the remainder is equal to value of the polynomial px at the 0 of the divisor. So by using the remainder theorem, we can easily find the remainder without not doing the actual division. Now let us do one example that find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1 or by 5 plus 2x. Here we will not use the actual division process. We simply, by using the remainder theorem, we will find the remainder. So let us consider px is equal to x cube plus 3x square plus 3x plus 1 as the dividend and gx is equal to x plus 1 as the divisor. Then the 0 of the divisor x plus 1 will be here minus 1. That is, if we put x plus 1 equal to 0, we get x equal to minus 1. So minus 1 is the 0 of the divisor x plus 1. So now if we replace x by 0 of the divisor, that is replacing x by minus 1 in px, we get p of minus 1. So that will be equal to, we just replace x by minus 1 here. So minus 1 whole cube plus 3 into minus 1 whole square plus 3 into minus 1 plus 1. So this becomes minus 1 plus 3 minus 3 plus 1. So here we are getting the value of p of minus 1 is equal to 0. So by remainder theorem, we get the remainder 0. 0 is the remainder when px is divided by gx. So in this case, we get the remainder here 0. Now let us consider another question here. Find the remainder when px is divided by 5 plus 2x. Here the divisor is 5 plus 2x. So the 0 of the divisor 5 plus 2x will be, we get 5 plus 2x equal to 0. We get the 0 of the divisor x equal to minus 5 by 2. So the 0 of the divisor is divisor 5 plus 2x is minus 5 by 2. So replacing x by minus 5 by 2 in px, we get p of minus 5 by 2 is equal to minus 5 by 2 whole cube, then plus 3 into minus 5 by 2 whole square plus 3 into minus 5 by 2 plus 1. So here we get minus 125 by 8 plus 3 into 25 by 2, by 4 plus, minus 15 by 2 plus 1. So after doing the calculations, we get the required remainder, which is p of minus 5 by 2. So after doing calculations, we get here p of minus 5 by 2 is equal to minus 27 by 8. So by remainder theorem, minus 27 by 8 is the remainder when the polynomial px is divided by a linear polynomial 5 plus 2x. So in this way, we can find the remainder by using the remainder theorem. So you try some questions which is given in your book. I hope all of you understood whatever discussed today in this video. So thank you all of you and have a nice day.